Hello dear students, in today's lecture we will study big theta notation. Previously we have studied big O notation and big omega notation for time complexity and space complexity, and now comes the big theta notation. Big theta notation, or simply theta we can also say, defines exact order of growth of time taken by an algorithm or code with the input size. So here study this line. It defines the exact order of growth of time taken by any algorithm. While in big O notation we have found the upper bound, and in big omega notation we have found the lower bound. But in big theta notation, the theta notation defines the exact order of growth. Exact, not lesser or lower, not upper or greater. It defines the exact order of growth of time taken by algorithm or code with the input size. So, theta notation defines the exact order of growth, not any lower bound or upper bound, just the exact bound. And now, let f of n define running time of any algorithm. So, f of n defines the running time of any algorithm, and f of n is said to be big theta of g of n. This is the theta alphabet in Greek language. So, f of n is said to be big theta of g of n if f of n is big O of g of n, and at the same time f of n is big omega of g of n. So, f of n should satisfy two conditions. It should be big O of g of n, and at the same time it is supposed to be big omega of g of n to be big theta of g of n. Both should satisfy. Now, mathematically we can say 0 lesser equal to f of n lesser equal to c1 g of n for all n greater equal to n0, equation 1. We also studied this equation previously in our big O notation. Now, this equation means that f of n is big O of g of n. Now, we have our equation 2, 0 lesser equal to c2 g of n, and c2 g of n is lesser equal to f of n for all n greater equal to n0. This is our equation 2. And what does equation 2 mean? Equation 2 means that f of n is big omega of g of n. We already studied this equation 2 in our big omega notation. Now, combining or merging equation 1 and 2 we get. From equation 2 we have 0 lesser equal to c2 g of n lesser equal to f of n, and from equation 1 we have f of n is greater equal to 0 and lesser equal to c1 g of n. Combine this for all n greater equal to n0. This is our equation 3. Now, equation 3 simply means that there exists, this is the symbol of there exists, positive constants c1 and c2 such that f of n is sandwiched. Always remember, it is sandwiched between c2 g of n and c1 g of n. So, from this graphical representation, we can say that this is the x-axis representing the n, and this is the y-axis representing the time. And these are our functions represented graphically. This is c1 g of n, this is our c2 g of n, and this is c2 g of n, this function, this is c1 g of n, and this is our f of n. You can see that for here we have our n0, and for all n0 lesser or equal to n, we have our conditions satisfied. That is, f of n is sandwiched between c1 gn and c2 gn. So, thus f of n is big theta of g of n because it is satisfying both. It is at the same time big O of g of n and big omega of g of n. By this graph, we can easily see that. Thank you.